Hi, welcome to my channel. I wanted to publish a small, fun program about how to animate sprites. I'll step through how to create a complete character that can walk forward, backward, left, and right. This character will also be able to go through casting motions and slashing motions complete with a spell effect and short sword. I begin in Tutorial 1 with a simple sprite against a filled background. Although the image isn't animated, it can be moved using the arrow keys. In Tutorial 2, I animate the sprite. In Tutorial 3, I add an environment, a green lawn. However, the PC can still wander off the lawn. In Tutorial 4, I constrain the PC's movement so that it can only move from the middle of one tile to the middle of the next. Also, I will add several more animations to the PC character. In Tutorial 5, I add obstacles to the player's world. Now, because of these obstacles, the PC cannot travel off the sides of the grid. In the final tutorial, I add additional animation sequences to the PC, giving it the ability to turn right, left, up, and down while moving from tile to tile. The player's movement is constrained by boundary tiles that act as obstacles. Okay, let's get started. Program 1, Tutorial 1. Here is what the first program looks like. It is a very simple program and consists only of two classes, the player class and the game class. As is suggested by the names, the player class is controlled by the game class. Notice that the player class is a sprite object. Here's the code for the player class. Well, that's the initialization function. Now let's look at the lines that read in our image. Here we're simply forming a path by using the path join function. By the way, I use the join function rather than specifying the path itself, so that the correct path will be formed regardless of whether the program is run on a Mac or a PC. Next, let's look at two very important object variables for this class, self.image, self.rec. Let's look at the lines that make everything in our graphics class work. Since the player class inherits the sprite class, this means we need to specify two things, self.image and self.rect. Fortunately, the code for this is easy enough. And I've put that code up there on the screen. We use the following code to start the program. And there is the main function that gets everything going. So this runs the initialization function of the game class. As you can see, the first thing we do is initialize the graphics. I'll let you go over the code for that. It's pretty straightforward. And by the way, here's the constants file. As you can see, this is where I set the title as well as the size of the screen. I'll be using the same constants file for all the tutorials in this video, so if you want to decrease the size of the screen for any of the tutorials, just decrease the tile size. I'm suggesting that the tile size be manipulated rather than say the number of tiles, because if the number of tiles is adjusted, then the environment class will have to be adjusted as well. That could be a lot of work. So that's my recommendation. Now let's look at the main function of the game class. You can see that up there on the screen. As we saw when we looked at the initialization function of the game class, self keep looping has been set to true. Because of this, the while loop is entered. I set the frame rates to 40, but you can fiddle with that. I found that anything between 10 and 60 works fine. Another really important function in this program is the handle events function, and there it is up on the screen. If anybody else has watched any of my other videos, this should look pretty familiar. If a person clicks the window closed or presses the escape, this will set the keep looping variable to false and the program will end. Otherwise, if a key is pressed, the program checks to see whether the key that was pressed was one of the 4 arrow keys. If it was, then the appropriate direction is recorded. Next, self-update is executed and the update function is called. And here's that code. Depending upon which arrow key you pressed, the move function will send you right, left, up, or down. And here's that code. As you can see, depending upon which axis, the X or the Y, received the 0, that axis will not be affected. The other axis will receive either a 1 or a -1. As a result, that axis will be either negative or positive. Since this is a very simple program, we don't need to record the X and Y values. Looking back at handle events at the bottom, we can see that when a key is raised, direction is set to idle, and so X and Y are both set to 0, and the image does not move. That leaves only one more function. So now let's look at the draw function. The line that fills the screen, self screen fill, floods the screen with the ugliest shade of pink you're ever likely to see. You can of course change the color value. I use ugly pink because I won't be using it for any of my tiles. As a result, if there are any gaps between the tiles, they will be easy to see. All sprites adds the sprite we created to the sprite group. Then all sprites draws the added sprites to a screen. Finally, Pygame display flip presents the drawing surface to the player. And that's it. Now all that is left is to run the program. This very simple program draws a sprite to the screen, and then we can move it around using arrow keys. So this is Program 2, Tutorial 2. First I'll go over the idea of implementing an animated sprite and then take you through the code. So, the idea of implementing a sprite. In the first program, we set up the mechanics of moving an image around the screen. In this program, we will make one change. Instead of moving just one image around the screen, we will move an animated image around the screen. All we have to do is read in a series of images into a list, set up a counter, and then step through each element of the list until the end is reached. At that point, the index is set to 0, and we start looping through the list of images again. That's the essential idea. Since we are implementing the player class as a sprite class, which is to say that the player class will inherit the sprite class, we will need at each tick of the clock to set self-image and self-rect. But as we will see, this is easily done. The big change that I've made is in class player. Instead of reading in one image, I read in a series of images that I store in a variable I've named ImageList. Since, however, the player class is our image class, we need to set the self-image and self-direct variables. Here's how we do this. And those are the lines there. At this point, we have a series of images stored in class player. Now we need to, at each tick of the clock, advance through our list. At the end of the list of images, we reset our counter and then start back at the beginning. Here's how we do this. In class game, we have added an update function. Note that the first two variables we send through are some combination of 0 and 1. Looking at the definition for the move function, you can see that the zeros and ones are used to steer the image by moving them along either the x or y axis. But that's not all. We need to tell our self-x and self-y variables what we've done, so we add these values here. Self-x and self-y are used to remember where the player is. We'll need that at each tick of the clock. Now let's look at next frame. Here's the code in which that function is called. Every time self-player moved is called, we call the next frame function. As the name suggests, this code grabs the next image from the image list and uses that image to set self.image and self.rect. Okay, almost done. Now let's look at the draw function. To draw the player on the screen, all we need to do is wipe the surface and reset the sprite group. Then we add the player sprite to the group. Finally, we draw our sprite to the screen and then display that screen to the player. Finally, running the program. So, in summary, as you have seen, this was a very simple program, but hopefully it demonstrated the basic idea behind the more complex animations we will look at. As we saw, to animate an image, we simply read in several images into a list and then each tick of the clock advanced through that list. Each time we did this, we grabbed the next image, used it to set self.image and self.rect. That's it. Tutorial 3. In this tutorial, we will be moving an animated image, and this is still a single animation, freely on a background of green tiles. In this tutorial, the big change will be to the background. Animations are wonderful, but often we want to animate a figure because we want to use it in some sort of game we are programming. Given this, chances are that there will be some sort of class that controls the environment. What I do here is look at how to hook up an environment class to the program. By the way, if all you're interested in is making a more complex animation and completely devoid of talk about the environment, then you might think about skipping ahead to the next tutorial, Tutorial 4, adding an environment. You can see here from our import statement that from the environment module, we're importing the Walkables class. Now, let's look at the initialization statement for our class game. You can see the change right there. We're initializing the Walkables class, and to do that we have to send through the name of the zone that we want to get the map from, as well as the specific map zone. And I'm doing it like this because I have set things up this way for my main game that I'm going to be using this animation in. So I'm keeping the structure as similar as possible, so it'll make it easy for me to fit this more complex body animation into that other program. Oh, and by the way, all my code is up on my GitHub. I'll put a link to that in the description below. Let's take a look at the Walkables class now. There is the initialization function, and here is these functions, read data in the game class, which calls the read data function in the Walkables class, and the code is up there on the screen. In order to read the Walkables class, all we have to do is call the appropriate read data function. As you can see, the function loadMap does what it says. It loads a map into memory, and I've put a picture of it on the screen. The function loadMap does what it says. It loads a map from memory, takes a look at the values of that map, translates those values into particular objects, and then loads those objects and displays the whole thing on the screen. And on the screen now, you should be able to see an image of that text file, the map stored in the text file. As I say, I've gone over creating and loading maps with the environment class in my series, Creating an RPG with Python and Pygame, so I won't go over it here. If you use the environment module and tell that module how to find the map, the code will work. Also, you will be able to run the environment module on its own, so you can test whether the module is working independently of the animation. I found that this makes debugging much easier. So next, drawing the environment. Here's the draw function in the game class. The line that we're particularly interested in is self.allSprites equals self.environment.update classes. And then we pass through self.allSprites. Here, what we are doing is we are asking the walkable class to add its sprites to our allSprites variable, and then we are updating self.allSprites. I'm not going to step through this code in more detail here, but if you have any questions for me, please do not hesitate to ask. I will read your question and reply to it. The summary of the program. The only change we made was in adding a background, a map, to the program, and that only took 3 changes. First, we added the environment object variable to the initialization function of the game class. Second, after we created an object variable for the game class, we used this variable to call the readData function and load the appropriate map. Third, after the map we wanted was loaded, we added one line to the draw function that loaded the walkable sprites onto our sprite group for display. If you're not used to programming with sprites, this may seem very odd, but it is actually quite quick and simple compared to every other way I've tried. Again, if you have any questions for me, please do ask. Program 4, Tutorial 4. In this tutorial, I will make 2 big changes. First, I will give the player more animations. I will give the player the ability to either walk, slash, as with a sword, move his arms about in a casting motion, or, lastly, fall down. Second, the player is now able to move in one continuous motion from one tile to another. This accomplishment was the most important to me, since the game that I'm creating evaluates the character's movements tile by tile. As a result, I never want my player to be, for example, on the edge of a tile. Let's look at these. Part 1. Implementing more animations. Here's the code for the initialization function in the game class. As you can see, I've changed the readData function by adding the player object and reading in some data using that class. I did that because things are now a bit more complex. Before, when there was only one behavior, walk, one simple load procedure was adequate. Now that many more behaviors are being added, it is convenient to put everything inside a readData function. Here it is. Note here that 2 functions are being used to call functions that return a list filled with images. The first is readInImageListComplex, and the second is readInImageListSimple. The rest of the readData function looks at which animation we want to begin with: walk, idle, slash, unconscious, or fall. This information is set in the initialization function of the player class. And as you can see, self.movement is being set to idle and self.direction is being set to right. We will look at the direction variable more in the next tutorial. In this one, we're really only going to be concerned with movement. Okay, so now let's look at the ImageListFall object variable that is going to store what is returned from readInImageListSimple. Before I unpack this function, let's look at the file directory. Inside the data directory, you will notice the images directory. Within the images directory are a few images that are used to draw the background. Of relevance here is the characters directory. Within the characters directory is one named Baldric. I did not make this animation. I downloaded it from a website. I do highly recommend the website though. It's called Open Game Art. The person who posted these images for download is Red Shrike. I put this person's URL in the description and I've shown it there on the screen. To the best of my knowledge, this artwork can be used by anyone as long as attribution is given. If you follow the indicated link, you will see the relevant copyright notices and can download the figures for yourself. I've also included them in my repo on GitHub. So anyway, I'd just like to say a heartfelt thank you to the kind and generous artists who spent their time developing these wonderful resources. That's awesome. Back to Baldric. As you can see, there are 6 directories there: fall, idle, slash, spell, unconscious, and walk. Here is what the fall directory looks like. You should be able to see that image on the screen. Not all directories are this simple. For example, here is the walk directory. Instead of files, we see 4 other directories: back, front, left, and right. Here are the files inside the front directory, and here is what those files look like. In order to explain this, let's look at walk versus fall. Notice that the walk directory is more complex than the fall directory because, while there is only one way to fall, there are 4 ways of walking. One can walk to the right side, the left side, the front, or the back. Let's look again at read in image list simple. There is that function. We would use this function to read in the sequence of images in the fall directory and the unconscious directory because they contain only files and not directories. So let's take a look. First, we form the correct paths. Since we are reading in the fall directory, the kind variable is going to equal fall. After checking that what we have formed is indeed a valid directory, we grab all the names of the files in that directory and then load each of those image files, transform them to make sure they are the correct size, and then add them to a list called images. Then all we do is return the list filled with images. The other function, read in image list complex, is exactly the same except for the addition of the variable name direction. As we saw, the walk directory contains 4 directories: left, right, front, back, and each of those is a direction. But after we've specified both the kind of movement we are looking for as well as the direction we are interested in, the function works the same way as read in image list simple, the one you just looked at. Okay, so now we have these lists: image list walk, image list idle, image list slash, image list spell, image list unconscious, and image list fall. And they are all filled with images. There is one final very important list, and it is called simply image list. Image list at all times contains only those images the program is currently drawing to the screen. To switch from one movement, for instance spell, to another, for instance walk, all we do is assign one of the movement lists to self-image list. For example, if I want to display the walk movement, all I do is assign that list to image lists. Now let's talk about displaying the images in self-image list. Okay, so you have these lists that are filled with images and you want to display them. To explain how to do this, let's look at the draw function in the game class. Notice that I've added the line self-update classes. Here's what that function looks like. Notice the final 2 lines of this function. In the first line, we call update classes on our player object, and in the last, we add the player object, which is the sprite, to the allSprites object variable. So far so good. All the interesting stuff is happening in the player's update class, so let's take a look at that. You can see that in the first 2 lines, self-counter is used to do 2 very important things. First, I select the appropriate image in image lists. Second, the selected image is assigned to self-image. And finally, I use that image to get the appropriate bounding rectangle and set self.rect. Now, let's look at how we move the animation. Moving the animation is accomplished by increasing or decreasing the value of self.x and self.y. Then we move the image's bounding rectangle and increment the counter. We need to check to see whether we have gone through the entire self.image list. We will have done this if self.counter plus 1 is equal to the length of self.image list. Note that the length of image list will vary depending upon which image list I set it to. First we set the counter back to 0. Then, if the movement was walk, we set the movement to idle. Simple. That is the general idea. In the next tutorial, the update classes function in the player class will become more complex. This is necessitated by implementing environmental obstacles, tiles that the player cannot move onto. Also, I switch between movements, for instance between walk and cast. But the idea is the same as I've demonstrated here. We'll go over all that in a moment. Now let's look at how we control the player's movements so that they always stop in the center of a tile. We've already seen how this is accomplished. You've just looked at this code, so forgive me for showing it again. This will only take a moment. As I mentioned, at some point we come to the end of the image in the list of images that compose a walk cycle. When that happens, we reset the counter. Now, since we've been incrementing self.x or self.y, it will be something like x equals 2.987 and y equals 1, or x equals 3 and y equals 5.123, and so on. That is, the value of x or y will be a float. We don't want that as a landing value, so we round self-x and self-y. This ensures that the image is placed firmly, securely in the center of the tile. If I don't do this, then the small errors in positioning would accumulate. And that's it. So, the summary of this particular program. In this tutorial, I made two big changes. First, I gave the player more animations. Now the player can walk, move his arms as though he is casting a spell, or swing his sword. Second, I gave the player the ability to move from the middle of one tile to the middle of another, simply by pressing an arrow key once. Now, on to the next tutorial. Program 5, Tutorial 5. The big change in this program is not with the animation of the PC. It is keeping the PC from wandering off the playing area. We do this by adding two things. First, we add an obstacle map, and second, we add code to the update classes function in the player class. Let's look at each of these. Part 1, adding an obstacle map. I've already shown you the map file I used for storing the data needed in the Walkables class. Here is that data file. I'm not going to step through the code because first, it works along the same lines as the Walkables class, and second, as long as you use the environment module and supply the correct path to the file, things will work. Third, I have explained these classes in detail in my series on how to create your own role-playing game. I also want to mention that if you want the full set of image tiles, you can download them from my GitHub repo. In this program, I've included a subset of those images since I don't use them all. The idea here is that if a tile is in the obstacle class, then the PC cannot walk onto that tile. The way that I keep the PC on the playing surface is simple. I surround that surface with obstacle tiles. Part 2. Adding code to the update classes function in the player class. I've shown you the map and how the obstacles are read in. Now let's look at the update classes function in the player's class. As you can see, I've added some code. At the beginning of the image list, I check to see whether, if a step is taken, the PC would collide with an obstacle tile. If that is the case, then the PC's movement is switched to idle and they are not moved. If, however, there is no obstacle on the space they want to move to, then I increment self.x. This logic is the same for each direction. Summary of the program. In this program, we have prevented the PC from wandering off the playing area. In the next tutorial, we will improve the PC's animation. When the player presses the right arrow, the PC will actually turn right. Similarly, when the player presses the left arrow, the PC will turn left. Also, I added animation for the spell. It's not a terribly good animation, but it will give you an idea for how to make your own. Program 6, Tutorial 6, the final tutorial. I've made a couple of changes here. First, I add a special effect so that when a spell is cast, something happens. Second, I make it so that when a player presses an arrow key, the PC will turn in the appropriate direction. Okay, so let's get started. Part 1, the special effect for spells. As you can see, we have added a new object variable to the game class, self.specialEffect. You could do this in various ways. It was easiest for me to load up the series of images I was going to use for the animation, keep them in self.imageList, and then display a transparent image until the animation itself is needed. So now let's talk about displaying the special effect. To display the special effect, we use this bit of code. Notice that self.specialEffect.show controls whether the special effect will display. We only want to display the image list once, so when the counter is equal to the length of the lists, we set the image counter back to 0 and set self.show to false. Then, if self.show is false, we need to set self.image to the empty image. However, if the counter isn't at the end and we do want to show the animation, we set the image to the appropriate image from the image list. Part 2, adding a turning animation. Another change I have made is, when the PC turns right, the animation is changed so that it will look as though the PC turns right. This is accomplished by adding a self-direction variable. As a result, we make small changes to the procedures we use to read in. Looking at the self-image list sheet function, now we have both a movement and a direction. Since we are displaying more behaviors, we need more lists to store the corresponding images in. Summary of the program. In this video, we have gone from moving a single sprite around on a plain background to moving an animated PC around an environment. We have also incorporated obstacle tiles, tiles the PC cannot walk over, to constrain the PC's movement. The next thing I will do is find a way to display the PC's health, probably with a red bar, but I will leave that for another program. If you have any questions about anything I've talked about, please don't hesitate to ask. Thank you for watching. If you have any suggestions for future videos, please do leave a comment. If you found this video worthwhile, please like and subscribe. Click the little bell to the right to be notified when I release another video. Be well and good coding.